In this video, we're going to go over more word problems related to exponential growth and decay. Specifically, we're going to go over simple interest, compound interest, and half-life. You will always be given these formulas. You just need to understand what the different parts of the formula mean and how to use it. So the first formula we're going to go over is simple interest. So let's go over those parts. So the big I stands for the interest earned. The big P stands for the principal. The R stands for the rate as a decimal. So anytime we get a percent, we want to turn it into a decimal. T is going to be the time. Now, a lot of times these questions will ask for the total balance. So we're going to have to add the original principal back with the interest. And I'll show you in this example. So it says Diana deposits $725 into a savings account that earns 2.3% simple interest. How much interest will she have after 1.5 years? So, and then what will be the account balance after 18 months, which is the same as 1.5 years. So the first thing, let's identify the different parts. So the starting amount is the principal. That's the starting amount that you are putting into the bank account. This is the rate, but we want to make it a decimal. So anytime we have a percent, we're going to move the decimal place over 1, 2 times. So my rate's going to be 0.023. And then time is going to be this 1.5 years. So my interest is going to equal P times R times T. So 725 times 0.023 times 1.5. So the interest she'll earn on the account is $25 and, well, we're going to round. So on my calculator it says 0.0125, but money only has 2 decimal places, and since this number is less than 5, it's just going to be 25 and 1 cent. So that's the interest, so that's the answer to the first question. The second question is, what's my account balance going to be? Well, the account balance is going to be the principal plus the interest. So I'm going to do 725 plus 25.01, so the account balance will be $750.01. So interest earned $25, account balance $750.01. Little typo there. We're going to use the same formula in the second problem. So we're going to use, because it talks about $550 deposited into a savings account that pays 7% simple interest. How much interest was earned after 4 years? And what will the account balance be after 4 years? So again, I equals, the principal is always the starting amount, so 550. Rate, well, my rate was 7%, but I need to turn that into a decimal. So remember the decimal spot is here, so 1, 2, so that's 0.07. And then the time is 4 years. So I'll have $154 earned in simple interest. Now to find the account balance, I need to take the principal or the starting amount and add it back to the interest. And so the account balance will be $704. So if we don't have simple interest, we have something called compound interest, which we're going to talk about next. Now, compound interest talks about how things are compounded. So if you notice in number 3, it says compounded quarterly. In number 4, it says compounded monthly. So we talked about that a little bit up here. So if it's compounded annually, that means once a year. So that's why our N in our formula is going to be 1. Semi-annually, like a semi-annual sale, that's twice a year. Quarterly, like quarters, there's 4 quarters in a dollar, so 4 times a year. Monthly, 12 months in a year. So for this compound interest equation, we're going to use our compound interest formula, which is up here at the top. So it's going to be A equals P times 1 plus R over N, and then N times T. So Let's talk about what those different things mean. So again, the P is the principal or that starting amount. So this is my P, the $1,200 that was invested. The R is your rate, but again, we want to turn that 2% into a decimal, so it's 0.02 because I moved the decimal spot over twice. And then it's compounded quarterly, so that means my N is going to be 4. And then 3 years means my T is going to be 3. So let's put all these parts into the formula. So A equals 1,200 times 1 plus 0.02 over 4. And I have 4 times 3 because my N is 4, so that goes in 2 different times actually. And my T was 3. So I'm going to simplify this first before I type in my calculator. So $1,200, 1 plus 0.02 over 4, and then it's 4 times 3, so to the 12th power. So I'm going to type this whole thing in the calculator, just like this with the parentheses and everything. So $1,200, 1 plus 0.02 divided by 4 to the 12th power. And I'm going to get $1,274.01. So again, with money, we're always going to have 2 decimal places. And so this will be my final answer. I don't need to add anything back like with simple interest. We just use the one formula and we'll get our final answer. Similarly, in number 4, we're going to use the same formula. So I have the principal, which was $15,000. I have my rate, but I need to go 1, 2. So my rate is going to be 0.048. And it's compounded monthly. So that means my N is going to be 12. And then 2 years, so my T is 2. So my account balance is my principal, so $15,000, times 1 plus 0.048 over 12, and then 12 times 2 power. So that's 15,000 times 1 plus 0.048 over 12 to the 24th power. And then I'm going to type that in my calculator. Make sure you use all the parentheses that are in there. And you will get $1,650.82. Our last problem is also on this page, is also a compound interest problem, so we're going to use the same thing. So principal, it's starting with $20,000. Rate, move that decimal spot over, so my rate is 0.052. Compounded semi-annually. So semi-annually means twice a year. So N is 2. And then my T is going to be 3. So my principal interest. So principal is $20,000 times 1 plus my rate as a decimal, 0.052, all over N, which was 2. And then 2 times 3rd power, so 20,000 times 1 plus 0.052, all over 2 to the 6th power. And then we're going to type that in the calculator. And we will get 23,329.97. So we got 0.968 in the calculator, but this 8 is going to make that 6 become a 7. So this would be my final answer. The last formula we're going to go over is half-life. And this is about how certain things depreciate by cutting it in half. So things like medication or certain compounds will decrease with a half-life. And so for half-life, we're going to use this formula up here. And so we're still going to have a P involved, meaning like that starting amount. This 0.5 will always stay the same because we're talking about half-life, so we're cutting things in half. And then our T is going to be our time. Actually, our T is not going to be our time. So actually, our T is not our time. That's a typo in here. I apologize. Our T is our number of half-lives. And we find that by doing a little formula basically to find the number of half-lives. So T is going to equal the total time divided by the time of the half-life. And we'll go over this in a second. So let's read this first, 7a. It says, astatine 218, that's just its name, has a half-life of 2 seconds. So that's really important. Find the amount left of a 500-gram sample, so that's going to be our principal, after 10 seconds. Okay, so the first thing I need to do is calculate the number of half times. So again, I'm going to take the total time. So the total time is 10 seconds. And I need to divide it by the time of the half-life, which was 2 seconds. So my T is going to be 5. Then, so I'm going to say A equals my principal amount, which was 500 grams, times 0.5 to the 5th power. Because again, my T is 5. And so after 5 half-lives happen, so this is 5 half-lives. That's how many would happen in 10 seconds. I would have 15.625 grams left. All right, so part B says, find the amount left from a 500-gram sample after 1 minute. So again, first we need to calculate our T. And my half-life is still 2 seconds. My total type, I don't want to put 1 minute up here because my units are different. Well, 1 minute is the same as 60 seconds. So in 60 seconds, if my half-life happens every 2 seconds, that means I'll go through 30 half-lives. So now I'm going to substitute this into the formula. So A equals 500 times 0.5, but now instead to the 5th power, I'm going to do the 30th power. We actually get a really small number in the calculator. We get 4.66. And they're using like E negative 7. That means 4.66 times 10 to the negative 7. So that's a really small number. And then let's do one more example like this, using our half-life formula. So I have isotope cesium. And it has a half-life of 30 years. If I have a 10-gram sample over 90 years, how much will be left? So again, the first thing I want to calculate is the half-life. So total time is 90 years, and then each half-life is 30 years. So that means it's going to go through 3 half-lives. So the starting amount was 10 grams. I'm cutting it in half 3 times. And once I do that, I'll have 1.25 grams of the material left.